Section 9.2, Part 3. Lesson objective. Construct and interpret a confidence interval for a population mean using technology. This will be Minitab and StatCrunch. Lesson objective. If you recall our commute time example from the previous video, a random sample of 300 students from this college was identified and the one-way distance each commuted was obtained. The resulting mean was 15.22 miles and the standard deviation was 5.95 miles. Estimate the mean one-way distance by using a 95% confidence interval using the sample data. Interpret this interval. So we know from this problem, x bar, sample mean, is 15.22, and s, the sample standard deviation, is 5.95. We know that alpha is 0.05 because we're doing a 95% confidence interval, and n is 300. Now we have to use a t-distribution because sigma, the population standard deviation, is unknown. Here we are in Minitab. So if we want to find the 95% confidence interval using the t-distribution, we go to Stat, Basic Statistics, One Sample T. We have Summarize Data, so we click Summarize Data. Sample size was 300. Sample mean was 15.22, and the sample standard deviation was 5.95. Now if we need to change the confidence level, we would go to Options and change it right here. The default's 95 and that's what we want, so we hit OK. We hit OK again, and in the session window we have our 95% confidence interval. Here we are in StatCrunch. This is how you compute the T 95% confidence interval using StatCrunch. We go to Stat, T Statistics, One Sample with Summary. The sample mean was 15.22. The sample standard deviation was 5.95, and the sample size was 300. We hit Next. We need to change from hypothesis test to confidence interval. The default's 95%, that's what we want. We hit Calculate. Here we have the lower limit. Here we have the upper limit for the confidence interval. To interpret this confidence interval, we would say we are 95% confident that the true population mean one-way distance to the college commuted by a community college student each day is between 14.53 and 15.90 miles. Let's look at another example. If you recall the highway signs example from the last video, suppose a highway safety researcher is studying the design of a highway sign and is interested in the mean maximum distance at which drivers are able to read the sign. The maximum distances in feet at which n equals 16 drivers can read the signs are as follows: 440, 490, 600, 540, 540, 600, 280, 440, 360, 600, 490, 400, 490, 540, 440, and 490. Construct and interpret the 99% confidence interval for the mean maximum distance a driver can read the sign. Here we are in Minitab. We're going to put in the raw data. So we go to C1 and we type in the raw data. Once you're finished typing in the raw data, 16 is our sample size, which is less than 30, we need to check to see if this sample is coming from a population that is normally distributed. The way we check that is we go to Graph, Probability Plot. We keep it on single, hit OK. Select C1, hit OK. And we see that all the points are within the bands. So this gives evidence that this sample is coming from a population that is normally distributed. So we may go on and complete our confidence interval. So we go to Stat, Basic Statistics, One Sample T. The raw data is in columns C1, so we click in this box, C1 comes up, we select it. We're doing a 99%, so we have to go to Options and change the 95 to a 99. We hit OK. And the session window mini-tab computes the 99% confidence interval. Here we are in StatCrunch. The raw data has been put in, var1. So to construct the 99% confidence interval, we first have to check the assumption that this data is coming from a population that's normally distributed, because we only have a sample size of 16. The way we do that is we go to Graphics and we go to QQ Plot. We select var1 and we hit Create Graph. We see these points follow this line pretty closely. We can continue to construct the T confidence interval. We go to Stat, T Stats, One Sample with Data. We select var1, hit Next, change it to a confidence interval, change the level to a 99, hit Calculate, and here we have our lower limit for the confidence interval and our upper limit. The way we interpret this interval, we would say we are 99% confident that the true population mean maximum distance at which drivers are able to read the sign is between 417.9 and 549.6 feet. Here's the reading and suggested problems. Thanks for watching.